Continuing the Challenge Rover build today on Mikey's lab. If you haven't already, go ahead and click that subscribe button down below to ensure that you get all the latest updates on science, engineering, DIY, making, and more that we put together for you every single week. Hi, and welcome back to my buddy's garage, apparently. Today we're going to be continuing the build of the Rover chassis, the base that we started in the last video. Now, believe it or not, in the week that I've had with this chassis, I've already decided to make changes. So we're going to cover those today, as well as attach the motors, attach the wheels, and attach the couplers to bring this into a full Rover base. The next step will obviously be to include the electronics that allow for radio control of the Rover. That will be back in our familiar lab setting, and I'm looking forward to it. So as I talked about the modifications that I've come up with, one of the things I wanted to do was extend the width of the legs itself. Okay, so if you remember correctly, we had these two pieces joined together with a 10 centimeter piece. We're going to increase that to 20 centimeters. The primary reason being that I wanted the inside of the base of the battery structure to fit in between here and be closer to each other. All right, so the other modification that we have done, we cut the brace that went in between the 90s for the middle section in half, and we've inserted these T-joints. I realized originally that I had not put in any provisioning for attaching the upper layers of this chassis. With the longer chassis, or with the longer base side as well, we're going to reconstruct the 10 centimeter channels for this side as well. I'm not going to make you watch me cut PVC all over again. I just wanted to recap what the differences were. One of the things you'll notice about the motors at this point is that we have the couplers attached. These couplers connect the output shaft of the drive motor to the tires themselves. Okay, so our next task now that we've gone over and talked about the modifications to the chassis so far is to connect the motors directly to the chassis. We're going to worry about the wiring later, so we're going to make them removable. By the time we put this on the roof, they're going to be either siliconed or hot glued in place to ensure that they're waterproof, but today we're focusing on the mechanical joint. So my idea for the mechanical joint is simple. As we talked about in the previous video, the motors fit perfectly into the PVC. So what I'm going to do is I'm going to cut some relief channels in the PVC itself with my Dremel. And then we're going to use hose clamps to clamp down the PVC onto the motors. This should provide us a fairly good rigid solution. When we're done, we will also have a brace plate that comes up and meets this hose clamp as well to hold everything in place, as well as our Hall effect sensors, so we can tell when the wheels are turning. Okay, so the first part of this process is to cut the relief holes into the PVC. Now, because this is my first attempt doing this, I'm not going to risk our finished part. I'm going to start with a piece of PVC we're not using, just to make sure my theory works. So we have a couple of scrap pieces from the pieces that we've replaced with the new pieces. I'm going to try the cuts with this one first and see if I can get a good grip off of the hose clamps alone. When cutting PVC with a Dremel, you want to go as slowly as possible. If you go too fast, you're just going to melt the PVC and it's going to gum up your cutting wheel and you're going to have no fun at all. Now, it goes without saying, when cutting PVC or any plastic with the Dremel, patience is your friend. If you try to go too fast, once again, you're going to start to melt, or you're going to torque on the cutting wheel itself and it will shatter and that will hurt you. So if we take a look at what I did there, you can see that there's a groove here and a groove here. We know that the motor is a millimeter smaller than the inside of this tube. So what I'm hoping is that this will provide enough that we can clamp down and just kill that extra millimeter and grab onto the motor really, really strongly. Let's see if I was right. This is one of the reasons I hate hose clamps. Because it's better if you have a socket set. Okay, so if we take a closer look now, you can see that I've got the hose clamp just to the point where it's about to start to tighten. So we're going to take one of our motors with a coupler in it, and we're going to insert it into there, and I'm going to tighten this down and see if it starts to hold. Oh yeah, there we go. All right, so with the relief cuts wider than we had originally anticipated, the motor inserted, and the cuts a little longer than we'd originally anticipated, this is in there and it's really not going anywhere. So now we're going to do the same thing on the actual legs. Okay, so if anybody was wondering why we didn't glue the last video round, this is why. We need to be able to take it apart to make it safe and easy to cut PVC slits into the legs and attach the motors properly. So I'm going to take our assembly that we're familiar with. I'm going to pull the legs off. So we have the two 10 centimeter, I think, 14 centimeter, sorry, and the one 18 centimeter piece that we're going to cut the slits into, attach motors to, and reassemble into the frame itself. I'm not going to make you sit here and watch me route this out every single time, so I will probably jump cut or fast forward through this part. Why do I always get covered in PVC dust on this project? It's like styrofoam. I hate this crap. Okay, so same principle. Once again, we're going to cut about an inch, a little more than the width of the cutoff disc, and we want it to be about 3 millimeters wide of an incision in both sides of the pipe. And you definitely want to be wearing your safety glasses when you do this. I can feel it bouncing off my forehead. And we're going to do the same with the other leg. If I can get it apart. Ugh. That's what I mean. Not sure I'm going to actually need the PVC glue. I now have a new reason to hate PVC. Sorry about your grudge, Benny. All right, so we're done with the Dremel. So we can take off the safety glasses that I can no longer see through. I'm gonna take a minute to have a drink and we'll be right back. Okay, so now we're at the assembly part. All the modifications to the pieces we need to do are done. I wanted to take a moment and talk to you about these wheels. One of the things to note is I only have 4 of them so far. The rest are stuck in some slow boat from our Far East friends. I'm sure I will get them in time to put this on the roof. But in the meantime, we're going to do this with 4 wheels. If you're going to put this outside, and this is going to operate in snow, and it's going to operate in all weather conditions, it's important to get real rubber tires. Right? These happen to have foam on the inside. They're designed for RC cars. They're not cheap. The couplers aren't cheap. Motors aren't cheap. So these are not the part of this robot that you want to go cheap on. This is literally the ability for your robot to move. Spend a little money, get the right tires. I'll leave links in the description below for the motors, for the couplers, and for the tires. So let's go ahead and start attaching these to the individual legs, and then we'll mount the legs back onto the Rover's chassis. When it comes time to actually do the assembly, we're going to grab a piece of PVC, Try to knock off as much dust as we possibly can. We're going to grab one of our clamps, put it over in place, slide that over top. Now, one of the things that you're going to want to do, you're going to want to make sure that this knuckle is on the inside away from the tire. If it's not, you're never going to get to it again, and it's going to be very hard to remove these wheels. We're going to get that as tight as we possibly can, and that isn't going anywhere. We're going to take some side cutters in a minute, and we're going to trim down this extra piece here so that it's out of the way. And we just do that 5 more times. So again, we take the piece, hose clamp, put it over top of the motor, make sure that the tightening section stays at the back of the motor. And get this as tight as you can by hand. If you're like me and 2 of your tires haven't arrived, make sure once again that the knuckle of the hose clamp goes on the back side of the motor. It's a little harder to tell without the tire in place. So once you've figured out what size these hose clamps need to be, you can go ahead and trim it. But you want to leave at least 1/2 to 3/4 of an inch of the actual band left so that we can easily undo it. I just use side cutters for this, bending it back and forth and weakening the metal. Until we have a much shorter piece there that we can bend in place and will not pierce the tire. I'm just gonna go ahead and do this 5 more times. You don't have to watch that. Tin snips, the right tool for the right job. All right, so what we have now is the leg firmly attached to the wheel and ready to mount to our chassis. It's one of the big ones, so obviously it goes onto the back. One of the short ones facing the front, we're going to use the wheels for the front and the back, and the ones that don't have the wheels will be in the middle temporarily. We're starting to get a pretty good idea of what this Rover is going to look like when we're done. All right, so at this point, we've pretty much finished off the mechanical build of the Rover. There's a couple more holes to drill, but we'll take care of that in our lab, and we'll jump into the electronics into the lab in 3, 2,
and we're back in the lab. If you're keeping up with us, we just finished the mechanical build in my buddy's garage. We're now back in the lab for some of the electronics components. I'm not wearing the lab coat because there still is some power tools to play with a little later. I'm going to talk about them and I'm going to do them off camera because it's just a simple couple holes that need to be drilled still. So what we're going to do first is we're going to set up the area that we will be drilling, and we're going to take a deep look at that side of things, and then we're going to create the wiring harness for the motors themselves. Drill bits. I'm going to pan down to the bench at this point. Any drill bits. We have the leg that we have already created. We're going to set that off to the side. This will be where all of the drilling happens. Actually, we're going to keep it here. We're going to keep it here. We're going to need our motors. I did get the other wheels at this point, so I now have enough wheels for the Rover. We are also going to need silicone wire. And it's very important to get the right type of wire for this type of application. You have to remember that this is going to be outside for an entire year. So it has to be able to handle high temperatures and low temperatures. And standard wire that has the plastic coating will have a tendency to get brittle and break with any movement that might happen at these temperatures. The silicone wire is a much better choice. It is rated up to 200 degrees Celsius. It will not get brittle, it will not bake in the sun, and it will not produce an arcing hazard for us. So I did get an entire box of it from Amazon. I'll leave a link in the description below. I left the link in the description of the previous video as well. And those links, just so that you are aware, and in full disclosure, are affiliate links. You don't have to buy through there. But if you do, the channel does get a little bit of a kickback for it, and it helps me cover some of the enormous costs of doing this channel. Okay, so we're going to start the wiring harness. Another thing you're going to need for this particular project, this particular part of the project, is XT60 connectors. Right, we are going to use these to connect the motor drive wires into the main robot so that the legs are still removable. We're going to have to come up with connector type later on for the digital signals going back and forth. I haven't figured that one out yet, but it's still bouncing around the old cranium. I've cut various lengths of silicone for the motor wiring harness already. And just to make it easier for us, the wire strippers, solder, of course my trusty Heiko soldering iron. Alright, so let's start building this. Let the soldering iron get up to temperature. Okay, so the first thing I want to do is I want to figure out which pieces go where. So I cut 2 long sets. And the idea of the long sets, I just measured these out honestly by putting it up against the frame and running it into place. There's a lot of extra wire here for various hookups and whatnot. I don't need them this long, but I figured the best way to measure them was to practically measure them. So the first thing we're going to do with these 2 sets, one of these is going to go to the back, and one of these is going to go to the front and get split right in here and come down to the motors there. Okay, so we're going to take 2 sets of the black, and we're going to strip those down. Like that. Twist them together. Like so. Okay. I'm just going to put this over that side there like that. Grab our soldering iron. Tin the soldering iron. Very important to always tin the soldering iron. You'll move the mic. I apologize if that creates a weird noise in the video. I'll edit it out. Okay. And then we're just going to touch the wire with the soldering iron. Touch the solder to the other side, and once it gets hot enough, it will flow and melt over, essentially making a very strong connection between those. Now we're going to do the same thing for the red wire. Grab the red wire, go back, the red wire, back, go ahead, twist these together, use the leg as a support once again. Soldering iron, which is still pre-tinned. And we're just going to go ahead and heat the one side until the solder can melt. There we go. Need a nice shiny solder joint. Just a happy solder joint. All right. So since this end is going to be the one that's here that brings in the motor power, let me just bring this over. That's in this section here on the bottom. Right, we're going to attach an XT60 connector to this. Now, an XT60 connector for this particular usage is overkill. An XT60 connector is designed to be able to handle up to 60 amps. There is no way that either of this side that all three of these motors are going to pull 60 amps. That would be an impressive feat for such tiny little motors. So if we take a look at the actual XT60 connector, and I'm just going to hit the button, you can see that there are two terminals, right? That come up with 2 pins. You obviously never want the male side of the connector to be the one that always has voltage. If the female side always should, it makes it much safer that there's not, 2 exposed pins here with large amounts of voltage with amperage behind it available to short circuit. So we're going to use this one on the leg, and then the wire that carries the voltage into this will obviously have the female. Now in the XT60, if we take a look at the side, I don't know if you can see this in the camera or not, but there is a positive marking on this side and a negative marking on this side. Negative being black, positive being red. That's how we're going to wire this up. Now, XT60s can be hard to wire and can be hard to solder because they have these giant metal plates in them that are what actually conducts the electricity. Having to carry 60 amps makes it hard. So the first thing you want to do every time is make sure that your soldering iron is tinned. That will help carry the heat down to the actual connector. And then we just want to fill this reservoir cup with solder, very much like so. Now, one thing to always be sure is as soon as you solder to this connector is like too hot to handle. So you don't want to do a lot of handling with it right after you're done soldering. So always let it sit, always let it settle for a second before touching it with your hand. You can, of course, use things like pliers or some type of clamp or anything really that will grab that isn't your hand to move it while you're working on it. And we just, once again, fill the cup with solder. Okay, so the negative is always on the curved side of the XT60. We're going to take our black wires. We're going to set them in place here. Very much like so. We're going to touch the soldering iron to the whole thing until everything melts. And then we get a good connection. Now we will heat shrink this connection in a second, just to make sure that doesn't go anywhere. In the meantime, I'm going to set my soldering iron down, let that cool for half of a second. I'll go ahead and grab some pliers here to be able to hold on to this, because even that black wire started to get really freaking uncomfortable to hold. Okay, so soldering iron again. This time we're going to grab the red wire. Right in there like that. I'm hoping that was all in shot on the SJ. What you want out the other end is, holy crap, that's hot. And you want the wires coming off of there and there. Again, as we can see here, you have a plus, which is now red, and you have the negative, which is now black. Now at this point, the next very important thing to do is heat shrink. Now, I did not set up my heat gun prior to starting to shoot this, so I don't know where the heat gun is. Okay, so one of the things that I failed to mention at the beginning of the video that we're going to need is some heat shrink tubing. Switch just over to the bench shot here, I'll show you what I'm talking about. This is a tube that when heat is applied to it, shrinks to half of its size. This will allow us to insulate the power connections for the motors so that we don't have to worry about shorts across that gap there. Yeah. These two are too big for what we're about to do, so I'm just going to cut them down quickly. The cleanest cutting apparatus, but it'll work. Okay, so we're going to take the black. And we're just going to feed that over top of the black wires and over top of the black terminal. And then we're going to take the red. And we're going to do the same. Go for the red wire. Alright, so as you can see there, they both cover the ends and the exposed parts of the connector very nicely. Now what we do is we take our heat gun. I apologize for the audio. We just start hitting it with heat. As you can see, it shrinks all the way around the connection. It isn't going anywhere, and will provide us with some nice insulation for the current. Okay. So now what we have is we have the two sets of wires. This connector is going to sit in the middle. This set of wires is going to come down to the motor here. This set of wires is going to come down outside of the tube and back in. So I want to leave a bit of slack. And we're going to just basically level these off. And then we're going to create the T-junction for going down here. So I'm going to pull these two to where they should be the same length. Like that. And then snip them off. So they are the same length. Next, I'm going to go ahead and strip the end of these ones off. Like so. Alright, now we're just going to twist the ends of the wire to make it more easy to work with. And we are going to grab two of those and these two as well. Okay? The reason we're grabbing two is because these two sets are going to come down the leg to the motor and hook into these, which are being fed from our motor controller. We're going to go ahead and rip off one end of these. Once again, we're going to go ahead and twist this so it's just a little easier to deal with. Okay, so we have the first set done. We're going to take the second set, same principle. Back them and twist the ends so it's easier to deal with. This. Okay. Now we're going to take the red wire, or the black wire, sorry. And we're going to twist these two together. And we're going to add the third. Once you get to this level of wire, it can be hard to do the physical mechanical joint, but this has to hold long enough to be tinned with the soldering iron. Once that's done, we'll tin the soldering iron, touch the wire itself. Until the solder flows nicely on all sides of this. Okay. Clean the soldering tip. For those of you have been with the channel for a while know I'm a little neurotic about a clean solder iron. But this is a Heiko that's almost 2 years old, and I'm on the same tip. It's because I'm not neurotic. Okay, so we have the first split part done. We're going to separate one side out. I'm going to pull it up like that. Then we're going to grab some heat shrink tubing. This time I'm going to go with a slightly bigger size because, yeah, it looks like it needs it. We're going to take the two ends here. Going to feed it through. This might not even be big enough. I might have to go one step bigger. See, no, I got it to go over. We're good. We're good. Alright, so you see how that's like that? So again, and that's going to ensure a very well insulated connection. Now we're going to do the same thing with the red wires. Okay, and there we have it. XT60 with two sets of wires coming out of it. One will be going to a single motor. So one will be going to a single motor, so there's absolutely nothing on the end of that one. The other set will be going to the front and going to two individual motors. So we've gone ahead and created basically a splice joint at the end here, right, which will allow power to be fed to both motors. So now, one of the things we have to work on is we need to drill the holes for running this through. Now I'm not gonna make you watch me drill holes. You're smart enough people to be able to drill your own holes.
Alright, so this is my fourth attempt to shoot this video. Between failed cameras, failed memory cards, and failed batteries, this has just been quite a struggle. I obviously can't show this from beginning to end since I've already completed both legs 2 times attempting to film this, so we're just going to cover the highlights, and I'm going to trust that you are smart enough to be able to feed some wire through a tube. Alright, so what we've done so far, we'll just go down to the bench really quickly here. You can see I have one of the legs with me. We have an XT60 connector coming out of there. We've drilled the hole to mount to the main body. The other one has 2 holes so that it won't pivot. This one has 1 so that it will. With the holes in the bottom, what we did is we drilled 2 holes for the XT60 connector, and then we connected it using a Dremel tool. One of the sets of wires comes out of the XT60, and as we talked about before, goes down and back to the rear motor. The other one comes from the XT60, goes up to the front, comes out of the tube here, loops back under into another hole that we drilled when we went off camera. I don't know how well you can see it, but it's right there. And once inside of this tube, it splits into the 2 to go to the motors. Now, one of the traps for new players with this that I wanted to talk about while we were doing this, and I'll just mention it here, is that the pins on the motor are labeled. One is red and one has no marking. It's very important that one leg has the red to the red and the other leg is reversed with black to the red. That way forward is the same regardless of which leg you're commanding. Otherwise forward will be one way on one and backward will be the other way on the other, and it'll just make software more confusing. So at this point that's very important. So what I'm going to do now is I'm going to bolt this chassis all together. And then I'm going to save the electronics for the next video, since this video has gone long enough as it is. That won't be far in the making. The first video that's going to be in the electronics series is going to be consuming iBus signals from a receiver into an Arduino so that we can control the rover with my transmitter for my drones. So I hope you learned something today. Thank you very much for joining me in the lab. If you haven't already, click that subscribe button down below, and I will see you next time.